Our last talk is by Brant Robertson, and he's going to be talking about the Jades imaging campaign.
Hey, good morning, good afternoon to everyone. Today I'm going to be talking about Jades, which is the joint NIRCam NIRSpec GTO survey. Thank you to the organizers for giving us the opportunity to talk about the survey. So Jades is a huge collaboration of many people. There are, as Stefano mentioned, more than 50 people in the collaboration. It extends over the entire globe, and maybe you could mute Dan. I sit on the steering committee, so there are two PIs, Marcia Ricci and Pierre Fruit. The steering committee is comprised of myself, Daniel Eisenstein, Roberto Maiolino at Cambridge, and Chris Willott at Hertzberg in Canada. Dan Stark is the publication coordinator, and there's a large number of people both on the NIRCam and the NIRSpec teams contributing, and I want to recognize their contributions, as well as the crows outside my window. So there's a huge range of science opportunities with Jades NIRCam. Many of those science opportunities have been spoken about today. I cannot possibly cover those in today's talk. So I wanted to give people as much information about Jades as possible and to tell you a little bit about what we've been doing to date. Jades started as a collaboration more than 5 years ago. And so we've been meeting regularly and doing work together as a collaboration in preparation for launch. And I want to bring people up to date on that and let them ask questions if they have any. So to give you an overview, like I said, Jades is a collaboration of NIRCam and NIRSpec. There's a series of observations that are scheduled, hopefully, over time, starting with some NIRSpec observations targeted on HST, then some NIRCam observations, then NIRSpec targeted on the NIRCam observations. I'll show you that in just a moment. The depths, here I have the 5 sigma point source depths. We reach deeper than 30 AB magnitudes at F200W. So really, this is uncharted territory, and some of the other programs will also reach it. It's really a remarkable survey. It's about the deep area in Jades is about 10 times the size of the UDF at similar depths, a little bit deeper. So it will be very, very exciting from that perspective. So the way that the survey is planned, and hopefully it will be scheduled in this way, initially there will be some in Good South, some HST observations, some HST targeted observations with NIRSpec during that time. You see those in dark green. During that time, in dark orange, we'll be imaging with NIRCam in parallel. Then we will also do NIRCam prime surveys, this deep area that you see in dark red, with NIRCam while exposing in MIRI in parallel. There will be some medium NIRCam prime observations taken with MIRI medium observations in parallel, and some medium NIRSpec observations targeted on candles with medium NIRCam in parallel. Then 45 days later, roughly, we'll come back, hopefully, with JWST and target deep NIRSpec observations on the JWST observations in the deep area of Jades, and also take some medium NIRSpec observations with NIRCam in parallel in orange that you see there. We have a similar program. Oh, this is the total program. Stefano showed you this. This field rotation is completely nominal. It depends on when the scheduling occurs, approximately plus or minus 45 degrees, and it depends on the observations being scheduled the way that they're presented here, and not using another observing window, of which there are a few. Then later on, we plan to target Jades Goods North. So this will be medium NIRSpec targeted with HST targets from candles, followed up with a medium NIRCam in parallel. And then we'll also do some medium NIRCam targeting with MIRI in parallel as well. And this is what we'll come back 45 days later, hopefully come back with the NIRSpec targeted on NIRCam, with NIRCam parallels off to the side, hopefully at an orientation somewhat similar to this. Again, it depends on the scheduling, whether or not this kind of field arrangement will actually be executed. And we hope that it is, so that the NIRCam observations that are taken in parallel. These orange fields fall on the HST imagery in Goods North. So, we've been talking about these observations, what actually goes into processing them. There's a huge amount. So for us, we have to go through a NIRCam oriented pipeline. We have to produce images and mosaics and detect objects, produce photometry, measure structural parameters, do some initial SED fitting, and then we can feed that information to NIRSpec to do targeting. They have to design their MSA, they have to acquire the data, and then there's some additional analysis. You can see it's doubled up here. We try twice as hard in Jades to do our analysis. So what we've been doing is doing simulations with Guitarra. This is the software produced by Christopher Wilmer at Arizona. This allows us to simulate the sky using an input catalog. And for this, we're using Christina Williams. I'll show you some of those simulations in a moment. We take these simulated observations and we mosaic them. We include distortion in these observations. I worked out the conversion between SciAF and SIP, so now we can use things like AstroPy, at least for NIRCam, to do our mosaicing and analysis. So we create a mosaic very carefully, keeping track of the error propagation. This is something that Sandro Tekello has worked very hard on. We do visit-based mosaics, and then we combine the visit-based mosaics into a larger mosaic. This produces an image, a flux image, error images. We get exposure maps as well. And that information is then fed into a pipeline that does detection. Let me show you some of these simulated observations. This is based on the Jaguar Mott catalog, Christina Williams catalog. This is a portion of the survey that you would see with Jades. This is a simulated F090, F200W, F444W image. And let me just zoom in several times so you can see the observations and the details that are available. We then have some kind of signal to noise ratio image that we stack together in a careful way, multiple different filter images from Jades. We then perform detection. This allows us to come up with a segmentation map. We can identify objects, and here you see the objects with their ellipsoidal isotopes shown. And then we record the information by measuring things using, say, SEP on the images as well. And let me just then raise a few issues I want everyone to think about. One is detection and deblending. This is an image of the segmentation map, and let me just zoom in a little bit. What's the best way of performing detection on these confused images? How are we going to do deblending? This is something that we're working hard on in Jades, but is not a solved problem by any means. We also have photometric validation. What's the best way to measure photometry in these crowded images? And we've been simulating this process from end to end in Jades and trying to improve our techniques. This is point source photometry. That's why it dips below the one-to-one relationship for very bright objects that are extended. Kevin Henline has come up with a new method for allowing us to inspect individual sources. So before we pass those sources on to NIRSpec for follow-up, we have to fit SEDs to them. We have to know what redshift they're at. We actually want to look at them in some detail. So Kevin has come up with a very a nice method to import all of that information from the mosaics and the SED fits and produce websites for each individual object in our catalogs, so we can go in and inspect them source by source to see how they're doing. We also have something called fits map. So once you have a very complex image like this and you want to lay down a bunch of slits, potentially how are you going to do that in a careful way? Well, we want to inspect the surrounding environment. We want to be able to interact with the data. So my student Ryan Housen has created something called fits map. This allows us to load in the images into a web browser. We can look at each individual image that we produce. We can look at combinations of the images. We can look at our segmentation map. We can overlay each individual catalog on top of the image. And then if we go back and we look at each object, we can actually click and interactively see all of the measurements in our catalogs. This software is public. You can download, pip install FitsMap and email me or Ryan, and we'll teach you how to use it. It's extremely helpful to learn how to interact with the data. It works on any data that's FITS-based and catalogs in standard format. So please let me know if you're interested in that. One thing we'll also be doing to try to augment our data is to do pixel level image classification of the Jades imagery. So Ryan Housen's created Morpheus, which is this deep learning framework for astronomical image analysis. And we scan through the images using convolutional neural nets and classify at the pixel level what the morphological classification of that region is, pixel by pixel. So we can tell where galaxies are disk galaxies, spheroidal galaxies, stars, compact irregular objects, or just background sky images. So it does do a form of detection as well. This is also publicly available, and please let me know if you're interested. So this will help us understand not just color relationships in the Jades data, but actually morphologically selected properties of galaxies as a function of time. So that will be very exciting. Okay, that's all I wanted to talk about today. So thank you very much for your time. I'm happy to answer any questions that people have about Jades. Thank you.
Thanks very much, Brant. So we'll wait just a little bit and see if any questions pop up in the Slack.
Yeah, my slides are available, by the way. You can download them. They're available on PDF. Hopefully other people can contribute their slides too for convenience. So going back to the question that was asked of Stefano about the release. So we would like to release some of the data. Whether or not, or the timeline for that release depends on how the data is scheduled. So as you've seen, for us to really optimize our survey, we have to come back with NIRSpec targeted on NIRCam imagery. There are really ideal times for doing that really enhance the science return of the survey. So, you know, our goal is that if the survey is scheduled in a way that enables that science to happen, then we'll try to release some of the data as soon as we can. Unfortunately, with the slippage of time and the way the windows appear, I'm not sure whether that data will become available before the cycle 2 deadline. Our observations would have just been taken just a couple of months ahead of December 2022, which is launch plus 13 for the cycle 2 deadline. If we can enable that to happen, we will do so. That since Good South is being acquired first, the public data that we would release earliest would come from Good South.
All right, so we've got some questions there. Steve, did you want to ask the one?
Yeah, sorry, I was just getting attacked by a bird outside. Brant has his problem with crows. I have problems with pigeons and seagulls. So regarding the source confusion, is this because JWST goes too deep and there are too many faint sources?
Yeah, it's hard for me in my heart to say that observations go too deep, but I think that's functionally what's happening. So if you go deep enough, then you start seeing the extended low surface brightness regions around galaxies, elliptical galaxies at lower redshift. The objects really do become confused. I don't have a number for what fraction they are, but you saw the segmentation map. The segmentation map is almost filled, and actually that's very difficult to do, to separate and de-blend out all of these sources, extremely challenging. So, so yes, in effect, there are many faint sources. There are many faint sources near bright sources. There are many bright sources that have extended low surface brightness features that then start to confuse the image. A lot of the pixels have detectable flux in them.
Thanks. The other question was not a question. It was just people are excited to use the tools that you all are making.
So this is some way that I think Jades can really contribute back to the community. So, you know, we're still working on our pipeline. Our pipeline is not yet public. A lot of these tools are public. FITSmap is public, so please ask me about that. It's such a cool tool. It's so fun to be able to zoom in on the data and pick it apart and click on sources and see what their properties are. I also really think that something like Morpheus will be very helpful to the other surveys, and we're planning to collaborate. And I'm personally collaborating with Ryan in some of the other surveys, and we'll do our best to try to annotate these images to produce as much information in them as possible.
So there was a question that just popped up. It says, does the code do well at identifying lensed objects? I assume maybe that's for Morpheus.
For Morpheus, so we haven't worked so much on the lens objects. We did work on the buffalo fields at one point, but we didn't pursue that much further. Those fields are extremely crowded. So we're still working on the performance of Morpheus in like strongly lensed fields. For individual lensed objects, or actually any of the tools, it's very difficult for us to say one by one whether an object is gravitationally lensed, if it's in the field, if it's lensed by a foreground galaxy lensing, or even galaxy lensing by some foreground protocluster or something. It's very difficult to do. So that's something we've talked about, but we haven't come up with a great solution for that problem yet.
All right, great. Well, thank you very much for this talk, Brant. Thanks to everybody who spoke in sessions 1A and 1B today. This concludes the first day of SAZERAC.